Welcome to myprojectbazaar.com. Now let's see about heterogeneous face recognition using kernel prototype similarities. Now let's see about the abstract. Here we propose the novel method to recognize the heterogeneous face. Initially, we have to remove the noise from the image. To remove the noise, we use the median filter. The system involved using a relational feature representation for face images by using kernel similarities between a novel face pattern and a set of prototypes. So initially we have to identify the probe image such as difference of Gaussian, center, surround divisive normalization, Gaussian image filter. So difference of Gaussian is a feature enhancement algorithm that involves the subtraction of one blurred version of an original image from another least blurred version of the original image. In the simple case of grayscale image, CSDN is an interaction between center and surround region of the receptive fields. A constant plus a measure of local stimulus contrast. Gaussian filter is windowed filter of linear class. By its nature is weighted mean is used for the denoising. After this process, we have to identify the shift and CLBP features. Shift represents the scale invariant feature transform. LBP represents the local binary pattern. So it is an algorithm to compute vision to detect and describe the local features in images. For any objects in an image, interesting points on the objects can be extracted to provide a feature description of the objects. And then finally it identifies the image. It will be retrieved from the database. This is the flow of our process. Here we have to given the input face image. The face image will go to the pre-processing step. Here we are removing the noise from the image. For removing noise, median filter are used here. So the underlying assumption is that neighboring pixels represent the additional samples of the sample value of the reference pixels. So the identified noise pixels will be removed from the images. After removing the noise, it will go to the three probe identification technique. Initially we are identifying the difference of Gaussians and CSDN, and the Gaussian filter techniques are applied. So after identifying these images, it will go to the shift and the LBP feature extraction method. Shift represents a scale invariant feature transform. It is an algorithm in computer vision to detect and describe local features in an image. For any object in an image, interesting points on the objects can be extracted to provide a feature description of the objects. This description, extracted from a training images, can then be used to identify the objects when attempt to locate the objects in a testing image containing many other objects. And then it will go to the local binary pattern. So it is a binary pattern for the images based on the difference between the images. If the center difference is greater than is positive, means the value will be allocated as 1. If it is negative, means it will be allocated as 0. Likewise, the binary pattern will be created. So after creating a pattern, it will go to the kernel similarity. Here we are identifying the similarity based on the distance between the database images and the testing images. So which image get the minimum distance, it will be retrieved from the recognized face. That is the final result of our process. Now let's see the demo of our process. Here I am having hetero-main.m file. Select this file, right click and run the file. So in dataset, I am having the sketch image as a input as a testing. In training, I am training the photo images of the related face images. So now I am giving the sketch images input. So for the sketch images, we are identifying the drop image. For the blob image, we are identifying the shift and the LBP feature. Based on the shift and LBP feature, it will be recognized from the sketch, recognized from the photo. This is the identified person of the given input. This is the original image. This is the denoised image. This is the different of Gaussian. This is the CSTN images. This is the Gaussian filter image. So this is the shift feature of dog image. This is the LBP image of dog. This is the shift feature of CSTN. This is the LBP image of CSTN. This is the shift feature of Gaussian. This is the LBP image of Gaussian images. So based on this feature extraction method, we are getting the features. These features will be mapped with the database images. So finally it recognizes the face images from the database. Now I am showing the result of heterogeneous face recognition using shift and LBP. It's showing the recognition. Thank you.